Hello, my name is Nitin. The MACPI system for in situ wireless power transfer compliance testing from SPIAG with its revolutionary 8-channel probe has been highly successful at solving the exposure evaluation problems at very low frequencies and very short distances for magnetic field sources. In previous videos, I had evaluated its performance, including the graphic user interface and application programming interface capabilities, and found that it was not only very accurate but also extremely user friendly. SPIAG has now gone one step further and redesigned the field probe and improved the evaluation algorithms. The result is MACPI 2. The obvious novelty of MACPI 2 is the flat probe tip. This is a major advantage as the four lower isotropic sensors are just below the surface. Since we have the measurement of the other four sensors on the back, we have a very accurate gradient information and can extrapolate to the surface here. A simple but very effective modification. It was more difficult to integrate the electric field sensor in the center of the surface here as well. In other words, we can now measure much closer to the surface of the transmitter as requested by the FCC and other regulators. I will quickly evaluate the emissions from this charger. First, I look at the frequency domain display and I see multiple harmonics of the dominant frequency of 128 kHz. The new multi-frequency exposure assessment feature of the MACPI 2 system has automatically detected all peaks which are within 30 dB of the dominant component, and these are marked with the dashed vertical lines. Let us zoom into these peaks and check their frequency and levels. So there are two peaks at 384 kHz and 640 kHz at field levels 2 and 0.7 ampere per meter, which are within 30 dB of the dominant component. The peak at 640 kHz meets the minus 30 dB criterion intermittently. The new MACPI 2 software version 2.0 automatically computes the exposure ratio for each dominant and harmonic component and adds these exposure ratios to compute the total exposure ratio. If I switch to relative mode and look at the numeric values, I see that the software has computed the factor XRT oblique XR0, which is a measure of the increase in exposure ratio due to additional harmonic components in the spectrum. Here, in this case, the value for this ratio at maximum exposure level is 1.04. In other words, the harmonic components contribute as much as 4% to the overall exposure ratio. Both the current and maximum values of XRT oblique XR0 since the last reset or clear operation are shown in the display. For this device, the incident H field interpolated to the evaluation surface is over 15 dB above the corresponding limit. But if we look at the induced E field, it is still minus 3.64 dB below the limit. This corresponds to a compliance gain of almost 19 dB. The local induced E field is also now assessed more accurately in line with the recent developments and research in this field. The local 1 gram specific absorption rate is almost 31 dB below the limit. SPIAG also mentioned that the calculation of induced E field based on the incident E field will also be available in MACPI 2.2. Thus, all compliance quantities required by the regulators are easily available on the MACPI 2 display. The new MACPI 2 is truly effective. I can now measure both the dominant as well as the harmonic components of the spectrum and evaluate overall compliance accurately in line with the latest FCC and ISED requirements. The graphic user interface is extremely easy to use, with compliance results available with a few clicks only. However, the most exciting new improvement is the ability to use the MagPi 2 system with the Daisy 8 robot. Based on the information I got from Swyag, it will use information from the 27 sensors directly. So I expect almost 8 times faster measurements than with version 1. And on top of that, I should also get the electric field information. I cannot wait to test it. Thanks for watching this video.